Assalamualaikum warahmatullahi wabarakatuh. We are from group 15 and our topic is elliptic curve cryptography. Next. Is Nur Aisyah Tasnim bin Muhammad Zainuddin, Nur Atira Elisa binti Rosli, Nur Shazwani binti Ahmad, Nurul Wajah Karimah binti Muhammad Shukri, Firas Amirah binti Rosni, and the last one Muhammad Faiz bin Musa. Next. Okay. Definition. Next. Elliptic curve cryptography (ECC) is a public key cryptography technique that uses elliptic curve over finite fields. In 1985, Neil Koblitz and Victor Miller proposed the concept on their own. The elliptic curve discrete logarithm issue is a well-known NP-hard problem, and the ECC is based on it. ECC is recently attracted a lot of attention in industry and academics as an alternative to existing public key systems like reverse Shamir Edelman (RSA) and digital signature algorithm (DSA). The fact that no exponential method exists to solve the discrete logarithm issue on a well-designed elliptic curve is the key reason for the attractive of ECC. Next.
So, for the introduction, cryptography is a vital branch of science that was established to allow secret communication and protect information. The two significant types of cryptography are private key cryptography and public key cryptography. In private key cryptography, a single key is used for the message encryption and decryption processes. It eliminates the necessity for the communication parties to agree on a shared key before the communication. Therefore, public key crypto systems were developed to address this issue, which uses a pair of keys, the private key and the public key. For many mathematicians and computer specialists, the elliptic curve crypto system is the most recent public key crypto system of interest. Elliptic curve crypto system security is unbreakable, unlike the RSA crypto system, which was established before the ECC. It allows for smaller key sizes while maintaining the same level of security, which is its main attraction. Next, I will pass to the next member.
Okay, next for the application. Elliptic curve cryptography (ECC) is one of the most widely utilized digital signature implementation approach in cryptocurrencies. Okay, it used for in the transaction, which is in order to sign transaction, both Bitcoin and Ethereum use the elliptic curve digital signature algorithm (ECDSA). ECC isn't just employed in cryptocurrency because of it employed in cryptocurrency. Okay, for the application, it used in transaction. In order to sign the transaction, both Bitcoin and Ethereum use the elliptic curve digital signature algorithm (ECDSA). ECC isn't just employed in cryptocurrency because of its shorter key length and efficiency. It is expected to be adopted by most online applications in the future. Besides, key agreement, digital signatures, pseudo-random generators, and other jobs, etc., can be gained from the elliptic curve by combining the key agreement with a symmetry encryption algorithm. By combining the key agreement with a symmetric encryption algorithm, they can be used for encryption indirectly. Elliptic also can be applied in different elliptic curve-based integer factorization technique with cryptography applications such as Lenstra elliptic curve factorization. Now I would like to pass to our next presenter. Thank you.
So the next session is advantage and disadvantage of ECC. So ECC, the advantage of ECC to decode an encrypted communication, ECC use relative short encryption key, a value that must be given into the encryption process. Other first generation encryption public key algorithm required more computer resource than this small key. 160 bit ECC encryption key, for example, provide the same level of security as 1024-bit RSA encryption key, while being up to 15 times faster depending on the platform. In the late 70s, Ronald Rivers, Ed Sharma, and Leonard Edelman developed RSA. First generation public key cryptography technology boosts RSA and ECC are widely used cryptographic protocol in wireless device when computing power, memory, and battery life are limited. The advantage of ECC over RSA especially essential. So for the disadvantage, one of the most major disadvantage of ECC encryption is that it greatly increase the size of encrypted message when compared to RSA encryption. Furthermore, the ECC algorithm is more complex and difficult to implement than RSA, increasingly the risk of implementation error and lowering the algorithm security. So that's all. I will give to the next presenter to continue the presentation.
Now we will focus on general explanation. Next. In the ECC, the private key are integer that are usually 256 bits integers in the range of the curve field size. A 256 bits ECC private key that has encoded 32 bytes and 64 hex digits can looks like this. And next, the key generation of ECC is as simple as secure producing a random integer in a specific range, making it highly quick, which is a valid ECC private key is any number within the range. Next, the public key of ECC are EC points, which are pairs of integer coordinates x, y that lie on the curve. EC points can be reduced to just one coordinate plus one bit due to their unique features, which are odds or even. As a result, the compressed public key is a 257 bits integer corresponding to a 256 bits ECC private key. The following is as an example of ECC public key, which is correspond to the previous private key, and it is encoded in Ethereum format as hex with prefix 02 or 03. Next. For standard ECC purpose, an elliptic curve is a plane curve over a limited space that made up of points simply following the general equation of elliptic curve. Any point on the curve can be mirrored over the x-axis in this elliptic curve cryptography example, and the curve will remain the same. Any non-vertical line that intersects the curve in three or fewer places will be considered non-vertical. That's all from me. I would like to pass to the next presenter. For the algorithm for this pseudocode, this program will generate key pairs and include the discrete message using elliptic curve cryptography, which is ECC. Function generate ECKs. Try get the elliptic curve cryptographic parameters using class ECName curve parameter spec and generate a key pair, which is a public key and private key using class key pair generator. Return by the generator key pair, cache exception, print exception, and return null and function. Function generate share secret private key and public key. Try get the key agreement protocol by using class key agreement. Initiate the class using private key and set through the key agreement protocol using public key. Generate the secret key. Return the secret key. Cache exception. Print exception, return null and function. Function includes string, which is secret key and plain text, size, specify and initialization factor. IV using class IV parameter spec. Use cipher class to obtain the type of algorithm that will be used for data encryption. Convert plain text to byte and save it to byte array. Initialize a new byte array. Ciphertext. Initialize the cipher instance and encryption mode. Encrypt the plain text and save the encrypted value in variable ciphertext. They convert ciphertext to hexadecimal. Return ciphertext, cache, print exception, return null, and function. Function decrypt string, secret key, and ciphertext. Try text. Description key equal to secret key spec secret key dot get encode secret key dot get algorithm cipher equal to cipher dot get instance AES GCM no padding BC byte ciphertext byte equal hex to byte ciphertext byte plain text equal to byte cipher dot get output size ciphertext byte dot length. Set decrypt length equal to cipher dot update ciphertext byte dot length. Set decrypt length equal to cipher cache exception print exception return null and function byte to hex. Return function byte to hex data dot length and function hex to byte data set length equal to data dot size set byte data equal byte length divide to loop I equal 0 and equal length data byte character dot digit string dot char at I 15 4 plus character dot digit string dot char at I plus 1 15 and loop and function main add bouncy castle provider library initialize plain text print plain text set key A equal generate EC keys set key B equal generate EC keys set secret key A equal generate share secret key A set secret key B generate share secret B print secret key A and secret key B set cipher text equal encrypt string secret key A plain text print cipher text set decrypt plain text equal decrypt string secret key B cipher text print decrypt plain text and return. That's all from me. Next, I will pass to the next presenter.
So for the mathematical representation, Next. What is an elliptic curve? An elliptic curve consists of all the points that satisfy an equation of the following form, which is y squared equal to x cubed plus ax plus b, where this equation is required to avoid singular point. So here above are some example below apa pula some example elliptic curve. So this is the example. So we notice that all the elliptic curve above symmetrical about the x-axis. This is true for every elliptic curve because of the equation of an elliptic curve is y squared equal to x cubed plus as plus b, and if you take the square root of both side you will get following the equation. So if you assign a as equal to 27 and b equal to 2, and you plug in s equal to 2, and you will get y equal to plus minus x. So the result in the point is uh 2, -8 and 2x. So next, the curve will look like this. So I will pass to the next presenter.
Now I will explain about the algorithm in detail. The most important characteristic of an implicit curve is that we can create a pseudocode for adding 2 points on the curve to obtain a third point on the curve. Okay, this addition rule satisfy the standard addition characteristics. Page 9. Abelian group is formed by the point and the addition law. To define addition for any 2 points, we must include an extra 0.0 which does not meet the elliptic curve equation. 0 is considered to be point on the curve. The number of unique points on the curve, including the 0 point, determine the curve order. Having established the addition of 2 points, we may define multiplication Kp as the sum of k copy of p, where k is a positive integer and p is a point. Um, let's say we have Alice, Bob, and Katie David. All agree on an unknown elliptic curve and an unknown fixed curve point f. Alice selects a secret random number a as a secret key and make public the curve point AP equal AF AKF as a public key. Bob, Katie, and David carry out the same. Assume Alice want to convey a message to Bob. One approach is for Alice to stimulate computer AKBP and use the result as the secret key for a conventional symmetric block cipher. Bob can compute his same number by calculating BKAP. BKAP equal to BK dot AFK equal AK dot BKF equal AKBP. The secret of scheme is based on the assumption that it include to compute K given F and KF. Next, choosing the fixed curve. A finite field is first chosen for appendix A. In the field is GFP, where P is a large prime. The XY term is omitted, leaving us with y power of 2 equal 3 x power of 3 plus ax power of 2, and plus b a where 4a power of 3 plus 23b power of 2 not equal to 0. Then choosing the fixed point for any point P of elliptic curve in the GFP power of M. Lim Kp equal to 0 for some and A and for some A and B is greater than A, we will have AP equal to BP. This implies CP equal to 0 where C equal to B minus A. The list C for which this is true is called the order of the point, and C must divide the order of the curve. For good security, the curve and fixed point are chosen so that the order of the fixed point F is larger prime number. This is done from the order of the curve, which is done from Scoff algorithm. I think that's all from me. I will give to the next presenter.
Okay, for the Java program explanation, okay, I will explain. First, we need to import all the related Java scripting and JavaScript into the project package. And we also need to import the bouncy castle and need to download some JRE and also use the JDK 18 on the Apache NetBeans version 12.6. Okay, first we need to create the class with name it as a project. Then for the encryption, first we need to make the plain text, and the user need to make some input, which is when we will require the user input, which we need to convert the plain text to the ciphertext. And for example, the user makes an input such as hi Michael, long time no see, want to get a lunch, we have got lots of cash out. So first, to make the encryption or decryption message, first we need to initialize two key pairs, which is we name it as a key pair A and key pair B. And then we need to create two AES secret keys. AES, as what we know, is Advanced Encryption Standard. Secret keys to generate the secret shared key with the method keyPair.getPrivate and keyPairB.getPublic. Here we will encrypt the message using secret key A. Okay, this code shows the process of displaying the output of encryption of the message using secret A, which is will print out the Alice sent this message to Michael, while the Michael get the public key, and while the Ellie will print out the private key. Okay, here this code shows the process of displaying the output of decryption of the message using secret B. Okay, to generate the elliptic curve, we need to generate the key pair by keyPairGenerator.getInstance with elliptic curve with ECDH and BC algorithm. For this code, this method, ECDH will be used for the purpose of key agreement. Method generate shared secret will generate a private key. for example, key DA and a public key QA equal to DAG, where we assume G is a generator for the curve. For the method encrypt string, okay, first we need to specify an initializer vector IV using class IV parameter spec, and then we use the cipher class to obtain the type of algorithm that will be used for data encryption. The numbers of round execute transformation of AES depends on the length of the cipher key, 6, 7, 8. It returns ciphertext into bytes to hexadecimal. And I forgot to tell you, this code shows the encryption of the secret key and plain text of ECC project. Okay, next. This code shows the decryption of secret key and ciphertext. It's almost same method or the process with encryption, but the ciphertext will be decrypted and save the value of decrypted in variable plain text. Okay, this code shows the bytes to hex method. It will change the bytes data to the hexadecimal data. This process will be used for the encryption message. Okay, here this code shows the hexa to bytes method. It will change the hexadecimal data to the bytes data. This process will be included for the decryption message. Okay, lastly, this is the output of the program algorithm or the programming Java. Sorry for the programming Java. This is the output, which is here we can see encryption process. First, I listen this message to Michael. Hi Michael, long time no see and blah blah blah. So here, public key. Michael got a public key. Y Alice private key. EC private key. Then the encryption key shared secret using the Java crypto spec secret. This message after being encrypted become this, which have a hexadecimal or ciphertext. Okay, for the decryption process, Michael received this message in encryption. Okay, for the decryption shared secret using by a Java crypto spec secret key, this message will be decrypted, and then Michael can see what Alice sent to him. Okay, I think that's all from me. Thank you.
Okay, for the conclusion, public key cryptography is very important to assuring data integrity and confidentiality and establishing a shared secret between two communication parties. ECC is able to provide confidentiality because it requires the hackers to solve the discrete algorithm problems to recover the plain text of the encrypted message. Security benefit of ECC is much more than RSA and DSA. A serious weakness in RSA is the sharp increase in key size is remunerated by smaller key in EC. ECC is additionally quicker for a variety of reasons. I think that's all from me and my teams. Thank you.
This is the demonstration of the source code, which is a Java programming. Okay, First, we show the code. Okay, now we run the code. Okay, here we will see the output, encryption process, and the decryption.